This video accompanies learning IoT with Python and Raspberry Pi. In this video, you will learn how to use several of the list methods, and you will also learn how to use lists with functions. For some of the examples in this video, you will need either a SenseHat device or a SenseHat emulator. We'll go to the Python shell and assign an empty list to the variable TheList. By entering the list followed by a period and then pressing the Tab key, we can display a menu of list methods. We'll consider 4 of these methods in this video lecture: the append method, the index method, the insert method, and the remove method. The append method appends the object to the list on which the method is called. The index method takes an object as an argument and returns the index of the first element in the list that has that value. A value error is raised if no element that has that value exists. The index method may also be passed arguments for start and for stop in order to limit the search to a range of indices. The insert method is passed the index where the object is to be inserted, as well as the object itself. The remove method removes the first object that has that value. If no such element exists, then a value error is raised. We'll write a script that keeps prompting the user to enter the name of an electronic component until the user enters exit. Each name will be appended to a list named components. We'll create an empty list and assign it to components. We'll use a priming read to read in component. The while loop will keep looping until the user enters exit. The append method is called on the components list, and the user is prompted to enter another name. We'll print out components after the while loop terminates. We'll save the script and run it. When writing the script, the programmer does not need to know how many names of electrical components users will enter. We'll write a script that keeps prompting the user to enter the name of an electrical component, and the index will be returned provided an element with that value exists. We'll create a list components that has the elements resistor, inductor, capacitor, inductor, diode, and sensor. The input function is again called to prompt the user for the name of an electrical component. And the while loop will terminate when the user enters exit. We call the index method with comp passed as the argument. And we'll print out the index. And again prompt the user to enter a component. We'll save the script and run it. First we'll enter resistor, and then we'll enter inductor, and notice that the index of the first occurrence is returned. If we enter a name of a component that is not in the list, for example LED, then a value error is raised. So that the value error will be handled gracefully, we can place the index method call within a try except statement that handles the value error. If the user enters a value that is not in the list, then the message invalid value, try again, will be printed out. We'll save the script and run it. This time when we enter LED, it says invalid index, try again. Because we used a try except statement to gracefully handle the value error, the while loop continues to loop and we're able to enter sensor and get the index for that, and then exit from the loop. Next, we'll write a script that prompts the user to enter a component and an index where the component is to be inserted. We'll add an input function call and convert it to an int type. The input function prompts the user to enter an index, and we'll call the insert method on components and print out components after the insert method has been called. We'll save this script under a different name. And run it. We'll enter the component LED and 3. Passing the insert method any index that is greater than the length of the list causes the object to be inserted at the end of the list. We'll modify this script so that it removes the component that the user enters. We'll save the script under a different name. And run it. And we'll first try resistor, and next we'll try inductor. And only the first occurrence of inductor is removed. We next turn our attention to lists passed to functions and returned by functions. As illustrated by this slide, a list can be created within a function and returned to the script or to the function that calls it. We'll define a function named createTemps that creates a list of temperatures that have been read from the sensat and which then returns a list. The createTemps function should be defined so that the number of temperature readings and sensat object can be passed to it. We'll import the sleep function from the time module because we wish to read the temperature in 1 second intervals, and we'll import the sensat class from the sensat package. If you're using the sensat emulator, replace sense_hat with sense_emu. We define the function createTemps to have 2 parameters, which will represent the number of readings and a sensat object. We create an empty list and assign it to temps. We assign 0 to itemp, which will serve as the counter. The while statement loops as long as itemp is less than ntemp. Each iteration of the loop, the sleep function is called, the getTemperature method is called on the sensat object, and the return temperature is appended to temps list. And finally, itemp is incremented by 1. This function returns temps. After the function definition, an instance of the sensat class is assigned to the variable sense. The createTemps function is called with the arguments 5 and sense, and the return list is assigned to temperatures. We'll save this as list return, and we'll run it. And yes, it really is this hot here. A list can be passed as an argument to a function. Because lists are mutable, a list can be modified from within a function. We'll define a function named addTemps that appends additional temperature readings to a list that has been passed as an argument. The addTemps function should be defined to have 3 parameters, which will represent a list, the number of temperature readings, and a sensat object. We'll import the sleep function and the SenseHat class. We defined add temps to have 3 parameters: temps, endtemp, and s. As in the previous example, we used a while statement that loops as long as the counter itemp is less than endtemp. Each iteration of the loop, the sleep function is called. The temperature is appended to the list temps, and itemp is incremented by 1. This function returns nothing meaningful. After the function definition, an instance of the SenseHat class is assigned to the variable sense. A list of temperatures is assigned to the variable temperatures. We'll print out the list temperatures before and after the addTemps function is called. The 3 arguments are the list temperatures, 5, and the SenseHat object. Because nothing meaningful is returned by the function addTemps, there is no assignment statement. We'll save this as listarg and run it. Before the addTemps function is called, the list temperatures contains 4 original temperature readings. After the addTemps function is called, the list temperatures also contains the additional temperature readings. Temps does not need to be returned by the addTemps function because it references the same list object as temperatures. Go to www.learningiot.net for links to where you can buy Learning IoT with Python and Raspberry Pi.